Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in your board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin-coated wearer board for your prototyping. Here we can check from the schematic that we have interfaced two relays with microcontroller, that is relay 1 and relay 2. And we have interfaced these relays with microcontroller using two transistors. Here we can find two general purpose transistors, that is C828, Q1 and Q2. And the bases of these transistors with the help of 2.2K resistors are connected with port RC4 and RC5. Here we can see digital output 1 and digital output 2. Digital output 1 is connected with RC4 and digital output 2 is connected with port RC5 of the microcontroller. Here we can see we have connected two diodes, that is diode 3 and diode 4, parallel to the coil of the relay. These diodes are called freewheeling diodes. And here we can find a RC network, that is 100 ohm 2 watt resistor and 0.1 microfarad 400 volt capacitor. This RC network is called Snubber Network, and we'll learn that what are the advantages of Snubber Network and what are the advantages of these freewheeling diodes. Relay is an electromechanical device, and here we can find a real picture of electromechanical relay, and here we can find the schematic symbol of relay. This symbol has a coil of electromagnet and a contact. If this coil will be energized, it will close the contact and current will flow from the source to the load. We can switch on and switch off different types of loads with the help of relays, that is electric lamps, electric fans, electric heaters and electric motors. Here we can see different types of relays are here, but the working principle of relays are same no matter what type of relay is there. Here we can find different terminologies associated with a relay. Here we can find a coil, it is an electromagnet, and we can find the contacts and poles. Here we can see the normally open contact, normally closed contact and the common pole. If the coil will be energized, it will attract the pole and the pole will be connected to the normally open contact. And if the coil will be de-energized, the pole will go back to the normally closed contact. Here we can find the electromagnet is here. If we'll connect this electromagnet with the power supply, the current will flow from the electromagnet and it will attract this lever, and this lever will displace the common contact, which is called pole. Here we can see we have a common contact and it is connected with normally closed contact. If the coil will be energized, this common pole will be connected to the normally open contact, and the contact between common pin and normally open pin will be closed. We can categorize different relays by their properties, that is coil voltages. We can find different types of relays in the market having different coil voltages, that is 5 volt, 12 volt, 24 volt, 48 volt and so on. And relays can also be distinguished by their coil current, that is electromagnet current. Similarly, we can distinguish different relays by their number of contacts, contacts current rating, and their types, that is latching or momentary. In a momentary type relays, we have a coil. If the coil will be energized, so the normally open contact will be closed, and if the coil will be de-energized, then normally open contact will be open. But in latching or bistable type relay, there are two coils. One coil is to close the contacts and second is to reset the contact. If you apply the voltages to the set coil, the contact will be closed, and if you apply the voltages to the reset coil, then contacts will be open. We can distinguish the relays by their contact types, that is single pole, single throw. Here we can see that we have a single pole and a single throw, and here we can find single pole double throw relay. It has a single pole and two throws. Similarly, we can have contact types, that is double pole single throw and double pole double throw. Here we can find we have two poles and two throws for each pole. If you would like to switch on and switch off a relay with the help of a semiconductor device, that is transistor, a diode is required to protect the semiconductor device, that is transistor, from getting damaged due to back EMF of the coil. Here we can check if this switch will be on. So this end of the coil will be positive and this end will be negative. But if the switch will be open, due to back EMF, this end of the coil will be negative and this end will be positive. So the energy stored in this coil will be dissipated across this diode, and this diode is called freewheeling diode. Now here we can find another circuit, that is called Snubber Circuit. The Snubber circuits are required to protect the contact of the relays from arcing phenomena. Here we can find a simplified electric diagram that how to connect a load with power supply and how to switch on and switch off the load manually. Here we can find a toggle switch. We can switch on and switch off the load with the help of this toggle switch manually. Here we can find in the selected diagram that how to switch on and switch off a load with the help of a relay. Here we can see we can energize and de-energize this relay with the help of micro switch. And the contacts of this relays are used to switch on and switch off the load connected with the power supply. Here we can find a supply of 220 volt AC, and this supply is connected to the normally open contact of the relay, and the common point is connected with the load, and the neutral is directly connected with the heating element. If we'll press the switch, the coil will be energized and the common pole will be connected to the normally open contact of this relay, and the current will flow from normally open contact to the common contact, and this load will be energized. Here we can find a freewheeling diode is here to dissipate the energy stored in this coil. In case if the switch will be open, the energy stored in this coil will be dissipated across this diode. And here we can find the Snubber network. Here we can find this Snubber network is composed of 0.1 microfarad 600 volt capacitor and 100 ohm resistor. We can also find open circuit breakout boards of Snubber network in the market. Here we can see a comparison of the relay contacts. Here we can see unused contacts are here. And here we can see contacts 100k cycles, that is 100k makes and breaks of the contact without arc suppression. It means that without Snubber network. And here we can see the conditions of the contacts. In third picture we can see the contacts, that is 1 million cycles. It means 1 million make and breaks of the contacts with arc suppression. And here we can find the condition of the contacts connected with Snubber circuits, that is arc suppression circuit. And here we can find the arc between two contacts. If you would like to control the relay with a digital device, that is a microcontroller in our case, we are using microcontroller PIC16F877A in our prototype. So we can switch on and switch off the relay using general purpose I/O. Here we can see we have connected our NPN transistor to switch on and switch off the relay. And we have connected the heating element with the help of the contacts of the relay. 220 volts are connected to the normally open contact of the relay, and the common pin is going to the load, and neutral is directly connected with the heating element. If the status of GPIO will be high, then transistor will be on, and current from the battery will flow from the coil of the relay, and relay will be energized. And if the GPIO of the transistor will go low, transistor will be off and relay will be de-energized. And here we can find we have connected a Snubber network for arc suppression. We can also develop a Snubber network by using 100 ohm resistor of 2 watt and 0.1 microfarad capacitor, 400 volt. Here we can find two different relays, that is 12 volt 10 ampere relay and a 12 volt 100 ampere relay. The coil current for this relay is 30 milliampere as it has a low ampere contact rating, but the coil current for this relay is 218 milliampere as this relay has a higher ampere current rating. We'll interface this relay with microcontroller. The coil voltage rating of this relay is 12 volt and the contact rating is 10 ampere at 250 volt. Here we have another type of relay. This relay has a coil voltage 24 volt and this relay is double pole double throw type. And here we can see two poles are here, and here we can see the normally closed contact and normally open contact of this relay. If this coil will be energized with 24 volt, so the center point, that is pole, will be connected to the normally open contact. Similarly, we have another type of relay. The coil rating for this relay is 12 volt and it is a 4 pole changeover relay. Here we can find 4 poles, that is pole 1, pole 2, pole 3 and pole 4. And here we can see the normally closed contact and normally open contact. Here we can find another type of relay. The contact rating of this relay is 100 ampere and the coil rating is 12 volt. And here we can find a common contact. This contact is called pole. And here we can see this contact is connected with the fixed contact. This contact is called normally closed contact. But if this coil will be energized, it will attract the pole and pole will be connected to the normally open contact of the relay. Here we can find a spring. This spring is required to force the common point to get in contact with the normally closed contact of the relay if the coil is de-energized. Let's see the operation of this relay. Here we have a 12 volt power supply. If I'll connect this power supply with the coil of the relay, it will be energized. Here we can check the common point is connected with the normally open contact of the relay. So if I'll remove the voltages, the coil will be de-energized and the common point will go back to the normally closed contact of the relay. Let's observe the working of the spring. Okay, here we have two relays. We have two green connectors to get output from the relay. Here we have 2.2K resistors, general purpose transistors C828, freewheeling diode 1N4148, and resistors and capacitor for Snubber network. Now we start developing the interface circuit of the relay with microcontroller.